Alright guys, so we're going to be going over assessment video number 5A, and the problem reads, an 80-kilogram man is standing on a scale in an elevator. He experiences the vertical velocity versus time shown in the graph above. What is the man's weight at t equals 1 second, 4 seconds, and 8 seconds? And so the way we can approach this problem is by thinking about it conceptually with the help of Newton's third law. So Newton's third law states that for every action in nature, there's an equal and opposite reaction. So if object A exerts a force on object B, then object B will also exert an equal and opposite force on object A. And so we can go ahead and visualize this by drawing a free body diagram. What we have here is an elevator. We have us standing inside of it. And so think about it in terms of Newton's third law. We know that for us standing in the elevator, we obviously have the force of gravity acting upon us. So that's just going to be our mass times gravity. And in order for the elevator to support us, it has to exert an equal force in the opposite direction. And so that force is called the natural force. And since we're applying Newton's third law, we know that the natural force is going to be equal to the force of gravity and vice versa. So taking this simple idea, we can write out that the summation of forces, which we know is mass times acceleration, is equal to the natural force minus the force of gravity. And so when we isolate the natural force, we get that we have mass times gravity plus acceleration is equal to the natural force. And when you simplify it, what that really means is just natural force equal to the force of gravity on us. And force of gravity is also just what we consider weight. And so we can see it both visually and derived from some form of mathematical derivation of how Newton's third law applies to us in an elevator. So taking this equation, we can go ahead and plug in all our numbers. What we want to find is the acceleration at time is equal to 1. Acceleration at time is equal to 4. And acceleration of time equal to 8. And so since we have the graph of velocity versus time, this is actually really easy to find acceleration, given that acceleration is a derivative of velocity, and the derivative is the slope of the graph of whatever we're graphing. So since we have velocity, we can take the slope of velocity to find our acceleration. So looking at the time 0 to 2, we know that 1 second is in between 0 to 2, and the velocity is linear, increasing. So whatever the velocity is at, or whatever the acceleration at 2 is going to be the same at 1. So what we can do is we can take rise over run. It's going to be velocity 8 over 2 seconds equal to 4 meters per second squared. And that'll be our acceleration at time is equal to 1. And then when we look at time is equal to 4 seconds, velocity is constant, so that means we have no acceleration. So that's just going to be 0 meters per second squared. Then again, for time is equal to 8, we can just do the same thing like we did for time is equal to 1. So we can take the rise, which is 8, over it traveled from 6 seconds to 10 seconds, so that's a difference of 4 seconds. So that'll equal 2 meters per second squared. And since its velocity is decreasing, we're just going to make that a negative. So now that we have all our accelerations, we can go ahead and find the weight of us at our different times. So weight at time is equal to 1, going to be 80 kilograms times gravity, which is 9.8, plus 4. And what we get is 1,104. And since weight is a measurement of a force, or sorry, I got that backwards. Weight is a force. We'd measure it in newtons. And we can do the same thing for time is equal to 4. So that'll equal 80 times 9.8, 0, since there's no acceleration. We get 784 newtons. And weight at time is equal to 8, equal to 80 times 9.8, 2, which is equal to 624 newtons. So at time is equal to 1, our weight is 1,104 newtons. At time is equal to 4, our weight is 784 newtons. And at time is equal to 8, our weight is 624 newtons. And we can go even further and go ahead and divide that by 9.8 to get an actual mass. So for instance, if we take time is equal to 1, take 1,104, divide that by 9.8, get that 8 equal to about 112, maybe 113. So when we're accelerating, our weight is kind of about equivalent to 113 kilograms. And then when we're decelerating, we can take 624 by 9.8 equal to around 64 kilograms. So that's why when you're going up an elevator, you tend to feel a bit heavier. And that's because the natural force is stronger as you go up. And so if the natural force is stronger as you go up, then the force of gravity is stronger going down. And then vice versa, if you're accelerating downwards, then the natural force is less, and so your force of gravity is less. And so this is a good example of Newton's third law. And thanks, guys.